Okay, so what we want to do is talk a little bit about absolute maximums, minimums, relative maximums. We're not going to do a whole lot of, let's say, heavy lifting with equations and stuff like that. I just want you to get a general idea of what they are, right? So, an absolute maximum, by definition, we have that the absolute maximum of a the, the absolute maximum value of f on some domain D uh, occurs when the value of the function at a particular spot is bigger than the value of the function at any other spot. Okay? So, what that means then, keep in mind f of x, these things are y coordinates, right? Look at my awesome writing. So, those are y coordinates. So, on a function with a maximum, an absolute maximum, what we're looking at, maybe we have something like this, is the highest point on the graph. So on this one, my absolute maximum would be here. Okay, and by a similar notion, the absolute minimum is the lowest point on the graph. Okay, now notice I have little endpoints on this graph and stuff like that. So this is the entire graph, right? Because I got little dots at the end here and here, not arrows. If our graph did something like this, there is no maximum because on this end it keeps going up farther and farther and farther. So there is no one high spot, right? There is no absolute minimum because on this side it keeps going down further and further and further. Now there could be more than one spot for an absolute maximum or an absolute minimum. Take, for example, if we think about the graph of cosine of x. Well, this isn't wanting to write very well. So if we think about cosine of x, that graph keeps doing this over and over and over. And I know it's not a great graph, but we'll get over it. And you see there's these high points, and they're all the same, right? So the highest y coordinate for this thing, the absolute maximum, is 1. Okay, because that is the highest point on the graph. It just happens to occur, well, infinitely many times for this graph, right? By the same token, you have a whole bunch of absolute minimums at -1 because that's the lowest y coordinate. Again, it happens to occur all the time, but that's fine. It has a high point and it has a low point, something that's higher than everywhere else or something that's lower than everywhere else. So absolute maxes and absolute mins are the highest point on the graph, the lowest point on the graph. Not everything has them. Some have 1, some have 2, some have infinitely many. Doesn't really matter. Then we have this idea of a relative maximum or a relative extrema. So when you see extrema, that word, extrema, that's just a catch-all phrase for min and max. Okay? So an absolute extrema, they would be talking about absolute maximums or absolute minimums. A local, or you'll also see the term relative, maximum or a relative minimum, just means in a small area around some spot, do you have a high point or a low point? Okay? So let's go kind of back to this graph. Um, that does something like this. Okay, there is no maximum, there is no minimum, absolute maximum or absolute minimum, but what you're looking for are like hills and valleys. So a relative maximum would occur right here because if you look in a little strip right around it, oh, let me undo that. That wasn't supposed to be red. If you look in like a little area right around this sucker, okay, in that little strip, it's the highest point, okay? That's what we care about for a relative or a local maximum or a local minimum. Like we have a local minimum right over here because in this little area around it, that's the lowest point on the graph. This is a local maximum. Okay. So notice on this graph, there is no absolute maximum or absolute minimum, but there are local maxes and local mins. And that will be true for, any number of like hills and valleys, right? I mean, I could do some kind of function that looks like this, okay? And it keeps going, and you're going to have maximums at all of these little hills. And then you're going to have local or relative minimums in all of these little valleys. So you can have more than one, that's fine. But the relative min, relative max, just any hill or valley. It doesn't have to be the highest one for the entire graph like the absolutes did. So there are, lots of functions that have those. You just have to graph them and see. I mean, just as an example, whoa, there I go being crazy again, moving stuff around. So if we think about something nice and simple, f of x equals x squared. Right, and we just look at the graph and say, okay, well, where do we have these types of absolute mins, maxes, or the relative extreme, or whatever? And just looking at the graph, you can tell there is no absolute maximum because there is no tallest point on the graph because it keeps getting higher and higher. There is no local max either, okay, because there's no little hilltop anywhere that you see. However, there are right here. This is a local maximum because it's certainly a little valley. It's lower than anything else around it. It also happens to be an, oh, I meant to say minimum. This also happens to be an absolute minimum because it is definitely lower than any other point on the graph. So some points can have both, right? It can be the lowest point on the graph, and it's also the lowest point right around it. Okay, so just look at graphs when you're looking for absolute minimums, absolute maximums. The max, in this case, the minimum value is at 0, okay, because that's the y coordinate, right? And this occurs when x equals 0. So you'll notice one thing with some of the phrasing in the questions. When it asks where something happens, we're thinking about the x coordinate. When it asks what the value is, it's always the y coordinate, okay? So value is the y coordinate. Where that occurs is the x coordinate.